Exponent laws. So there are some rules to combining exponents, and most of these rules will require the same base. You may see some similarities between these rules and some other things that you know about exponents. For instance, if you know about scientific notation, some of these exponent laws work there as well, and so you'll see the same sorts of laws being applied. The first rule is called the product rule. And the product rule says that if you have an exponent and you multiply it by another exponent and they have the same base, then the answer to this is a to the m plus n. So you add exponents. The only other thing about this is the base cannot be equal to 0. It's not allowed to be. So here's why this product rule works. A to the m is a times a times a times a times a times a, and you do that m times. And a to the n is a times a times a times a times a, and you do that n times. Well, if you multiply a to the m times a to the n, what you're really saying is a times a times a m times is then multiplied by a times a times a times a n times. And since the bases are all the same, if I just gave you that original thing, you'd say, well, there's a, and then there's more A's, and you'd have a total of, if this was 6 and this was 4, you'd have a total of 10. So it's just add up those two exponents. So here's a couple more examples. 2 cubed times 2 to the 5th. So by the law, I just add up those exponents since the bases are the same, and I get 2 to the 8th. If you want, you can calculate these out, but you don't need to unless it says to simplify. You can just state it as an exponent. 2 to the 8th is 2 times 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 2. You can do this on your calculator. 2, and there's a little up arrow on those calculators with an 8, and you will get 256. Note that the base stays the same. Let's take a look at the second rule. The second rule is known as the quotient rule, and this is used for division when you have the same base. So if you have a to the m over a to the n, you end up getting subtraction of those exponents. And there's just one restriction on this, which is a can't be equal to 0. So an example of this, if you have 4 to the 7th and it gets divided by 4 squared, you get 7 minus 2, so 4 to the 5th. And that works because 4 to the 7th is 4 times 4 times 4 times 4 times 4 times 4 times 4, and on the denominator 4 times 4. And whenever you have a fraction, you can cancel out common factors. You do that naturally with a number like 3 over 6. This is really 3 times 1 over 3 times 2, and you cancel so that you get a lowest terms fraction of 1/2. With exponents, I'm doing exactly the same thing, and so I get a final answer of 4 to the 5th. Let's move on to the third rule. This is the zero rule of exponents, and it says if you ever have a base with an exponent of 0, you get 1. So, for example, if you have 150 to the power of 0, you get 1. Or if you have pi to the power of 0, you get 1. There's still a restriction on this. The base can't be equal to 0. But it's a pretty straightforward rule. Then we can apply all of these rules at the same time. We call those sorts of questions combined operation. And the easiest way to see some of these combined operation questions is to give you a few examples. So here's the first couple, and the instructions on these are simplify but leave in exponential form. And the first one, I'll call it example A, is negative 5 to the 10 divided by negative 5 cubed times negative 5 to the 11th. So we follow BEDMAS here. We do adding, anything inside brackets. There aren't any. Then we deal with exponents, and exponent laws are exponents. So I can do the division of these exponents and then the multiplication. So the division will be subtract. So this will be negative 5, it's the base, to the power of 7 times negative 5 to the 11th. Since these are the same base, I can also work with that, and I get negative 5 to the 18th. Now negative 5 to the 18th, that's negative 5 times negative 5 times a whole bunch of times, 18 times. Since the 18 is even, the negative 5s, when they're written out, negative 5 times negative 5 times negative 5, 18 times, since they can be paired up, so there are 9 sets of 2 pairs in those 18 times. Since they can be paired up, this is an answer that's positive, because 2 negatives make a positive, 2 negatives make a positive, 2 negatives make a positive. And so that's really the same as, well, I don't really need these negative signs in here. So negative 5 to the 18 is exactly the same as positive 5 to the 18. It's a little bit tricky, but that is a nice simplification. There's no need to simplify this number, 5 to the power of 18. If you did, you'd have to use a calculator, and it would be an extremely big number. So when it says leave in exponential form, you leave it as a power, as a final answer. Let's take a look at another example. If I have 8 to the 10th times 8 to the 15th, and then it divides by 8 to the 40th. Again, I do BEDMAS, there's no brackets, so I go to exponents. I can do the multiplication. I'm not solving this actual exponent, so I'm kind of going on to multiplication and division. So I do the multiplication, that's 8 to the 25 divided by 8 to the 40, and they subtract, and you get 8 to the negative 15. Perfectly fine answer. Done. Other questions are going to ask you just to simplify, and simplify means when you get one of these final answers in exponential form, you do need to actually calculate what that's worth. So let me show you a couple of simplification questions. Firstly, 2 to the 7th minus 2 to the 5th times 2 cubed. So remember BEDMAS, we're going to need to use it. BEDMAS says any brackets? Nope. Exponents next. Well, you could actually go and calculate what 2 to the 7th is, and 2 to the 5th, and 2 cubed, and do this question that way. But we have these exponent rules that help us simplify some of these things. So I would skip doing exponents and go on to division and multiplication. So this stays as 2 to the 7th, but because these are multiplied and the bases are exactly the same, we have a rule that says that becomes 2 to the 8th. Then this isn't multiplied, this is added and subtracted. We don't have a power rule for addition and subtraction. We've got one for multiplication, we've got one for division, but we don't have any other power rules. We have one for 0, and that's it. So we do actually now have to add and subtract. And to add and subtract, we actually have to calculate 2 to the 7th and 2 to the 8th. So if you can memorize 2 to the 5th as 32, it really helps calculate these without having to go, okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, and to keep track of it. If you know that 2 to the 5th is 32, then 2 to the 6th is 32 times 2, which is 64, and 2 to the 7th is times 2 again. 64 times 2 is 128. And then 2 to the 8th is 128 times 2, which is 256. And since 128 is half of 256, when you add them together, well, the negatives win, and it wins by negative 128. Numbers are a little bit tricky, but knowing this 2 to the 5th is equal to 32 will certainly save you some time anytime you see a base of 2 and you have to work something out. Here's a second example, 5 squared times 2 cubed. Now, I see a lot of the times people just start trying to apply the exponent rules. Well, one of the key things about the exponent rules is the bases have to be the same, and in this case, they're not. So none of the exponent rules can be used for it. So instead, we need to calculate what 5 squared is and what 2 cubed is and write those down. So this is 25 times 8, and 25 times 8 is 200. Notice again, with different bases, there's no rule, so we just go and calculate it. Okay, we'll see you in class for some more practice.